Alright, in Lab 6, you're going to learn about absolute age. Let's look at a few definitions and terms before we continue. Well, absolute dating. Absolute dating is actually a term used for methods of determining numerical ages of rocks. Isotopic dating uses the natural radioactive decay to measure the age of the rocks. When dating, we look for unstable isotopes in a sample that we know to break down from the unstable to a stable material. This is known as radioactive decay. Isotopes are different forms of a single element. Their atoms have identical numbers of protons, but different numbers of neutrons. The decay or breakdown of unstable isotopes occurs at a particular rate, allowing us to determine the age of the rocks using the ratio of unstable isotopes present in a sample to the stable isotopes present within the sample. Parent isotope is considered, or what we call, the unstable isotope, and it decays spontaneously to another more stable element that we refer to as the daughter element, or daughter isotope. A half-life is the length of time it takes for half of that unstable parent isotope to decay down to its more stable daughter isotope. Let's say we start with 100 atoms of a parent isotope. So we have up here 100 and P representing the parent isotope. After one half-life, half of this sample will break down to a more stable daughter isotope. The other half will remain the unstable parent isotope. So after one half-life, we have 50 of the parent atoms and 50 of the daughter atoms. Let's say a second half-life takes place. Well, in this one, the daughter is not going to break down anymore. Only the parent is going to break down, only the unstable isotope. So in the second half-life, we see that 50 parent breaking down to 25 parent and 25 of the daughter. Now, if you were asked after two half-lives how much of the parent isotope and how much of the daughter isotope you have, the amount of the parent would be 25 atoms. The amount of the daughter is going to be that 25 plus that 50 from the first half to make 75. When you're asked at the end what the ratio is of the parent to the daughter, the ratio should sum back to 100, or the original value. In this case, 25 parent and 75 daughter to make 100 from the original. In activity 1, you're going to take 100 pennies or 50 dice, put them together, shake them up, and pour them out. You're going to count out the number of tails you have, which will represent the parent if you're using pennies, or all other numbers minus 6, which will also represent the parent if you're using dice, and record it in your table. On the other side, you're going to record the number of heads if you're using pennies, or the number of sixes that are rolled out of the 50 dice here. You're then going to pick up all the tails, or all of the dice that didn't roll a 6, and re-roll them again, or toss them again. This will be your second half-life. Again, count number of parents, number of tails, or number of dice that don't show a 6. On the other side, the daughter, number of heads, or number of dice that show 6. Again, you'll pick up all the ones that represent the parent, so that means all the tails, or all the numbered dice that do not show 6, and do this again. You're going to continue doing this until you've made 10 tosses, right? Or until you run out of pennies or dice and stop. Once you have this set, you're going to use this information from the table and record it onto figure 6.1, page 43. When you start, everyone's going to have either going to have 0 to 100 if you're using pennies. So you're going to put a point there. Or if you're using dice, you're starting with 50 dice. At the 0, you're going to put a 50. Then coming down from there, you're going to look back at your table and see how many of the tails you had left and record this. And then for 2, the same thing. Toss 3, the same thing, and 4. This is going to start to create a kind of curve on your graph. You're then going to use that graph to answer some of the questions in Activity 1. For Activity 2, you're going to determine the age of some given rocks. Here's an example of the calculation you're going to need to do for all the problems in Activity 2. If you were given a problem where you were told in your laboratory you counted 750 atoms of uranium-238 and 250 atoms of lead-206, how old is this rock? Right? Well, the first thing you're going to do is look over at Table 6.2 in your lab manual on page 45. You're going to determine which of these items is the parent and which one is the daughter. If you look at the table, uranium-238 in the table on page 45 shows under the parent isotope column. The lead-206 shows under the daughter. So we now know that the parent is the uranium-238, the daughter is the lead-206. The other information we gathered from that table is that the half-life of the uranium-238 is 4.5 billion years. Let's start by adding the two together. Take the parent, the uranium-238, 750 atoms, and the lead-206, which is the daughter, 250 atoms, sum them together. This gives you 1,000 atoms. Once you have the total number of parent to daughter atoms, you're now going to divide the amount of the parent by the total to give you a percentage. So I'm going to come back and take that 750 I know to be the parent and divide it by that total 1,000 atoms. This gives me a 0.75. To turn that into a percentage, I multiply by 100, which gives me 75%. I'm now going to move over to Table 6.2 on page 45, and I'm going to find out just how many half-lives have occurred. Looking at this table, running along the y-axis up and down is going to be my percentage. Running along the x-axis along the bottom is going to tell me number of half-lives. So I'm going to come in, well, on my calculation here I had 75%. So I'm going to come from the 75% line and I'm going to draw out until I hit that curve. So I come out and I touch this curve just out here, and then I'm going to, once I've touched the curve, I'm going to drop straight down. It's important here that you're very careful. You're going to need a straight edge. You're also going to need to make sure that your lines are coming out at 90-degree angles. Any slight change in the angle of your line can actually change the answer, and it'll give you an incorrect final answer. So I'm going to drop straight down from that point where my line touches that curve. So if I drop straight down, I see on this line I'm running between the 0 and the 1. And if I look at how many places are in here, this is counting every 0.2. So this is 0.2, 0.4, 0.6, 0.8, and 1. So between a 0.4 and a 0.6, it's halfway in between, so this has to be 0.5. So I know that I have had 0.5 half-lives occurred. So I'm going to come back, and now what I'm going to do is take that 0.5 that I got off my graph, and I'm going to multiply that by the half-life that I learned from Table 6.2. For uranium-238 to lead-206, I learned that the half-life is 4.5 billion years. So I put in here 4,500,000,000 years. I multiply them and I end up with 2,250,000,000 years, or 2.5 billion years. So my rock is 2.25 billion years old. You're going to do this for the given problems in activity 2. You're going to repeat this process 5 more times.